So now we're going to configure some interface policies, and this is normally something I try to address right out of the gate with ACI because these are really reusable objects in the form of policies that we can leverage throughout our configuration for many, many years. So to kind of give you an example of what the hell I'm talking about, we're going to cruise over here to Fabric, and instead of being in inventory or Fabric policies, we're actually going to be over here in access policies under the interface policies section. So right now, we're not talking about policy groups or profiles or interface overrides. We're really going to be talking about these policies within here, link level, CDP, LLDP. And again, these are things that we're going to be able to use over and over and over again. So I try to, basically configure everything that I can think of, through, knowledge or experience or whatever you have. And again, I try to do it kind of straight away. So what I'm going to do, and just to give you guys a pretty good example, we're going to configure quite a few policies in here. I'm going to start with link level policies, which are going to control things like speed and duplex. So if you know you're going to have 1 gig and 10 gig connections, maybe you want to come in and say, hey, I know this is going to be a static 10 gig, we'll leave auto negotiation on, but I'll turn the speed directly to 10. Okay, and we'll say submit. We could do the same, if you know you're going to have 1 gig connections. We could say this is going to be 1 gig auto on, and then speed is going to be 1 gig. So now we have policies, again, that we're going to be able to leverage till the end of time that are specifically for 10 gig and 1 gig connections. Okay, we also have the default, which is just auto on, and then inherit the speed based on the interface value. CDP. Another thing I just come in and kind of knock out. We know there's two combinations of CDP. We can have, CDP on, where CDP is enabled, which is the default. And then we have CDP off. And again, I'm pretty literal, right, with my ACI policy names because I find that's easier and everybody understands what CDP off is going to be. So we'll just say CDP off there. We'll disable that guy and we'll click submit. Same for LLDP, though there's a couple different combinations for LLDP in here. Basically, we have send and receive on and off, so there's 4 different policies that we need to write. So we'll say LLDP, TX, whoops, I said RX there. We'll say TX is going to be on, RX is going to be on, and we'll just leave both those enabled. Actually, let me copy this out. Make it easier on myself with the other ones. We'll say submit, and we'll create the other 3. So this time we'll paste this in, and I'll say RX is going to be off, and we'll disable that guy, and I'll click submit. We'll go back in here, create another one. We'll paste it in, and this time I'll say TX is going to be off, and we'll disable transmit LLDP. Now, will you always use all of these? No, absolutely not. You may never have a time where you need transmit to be on and receive to be off. But it's nice to have these guys in here. So we'll go ahead and say off, and then RX is going to be off, and we'll disable both of those guys. Okay? So now we can see we have 4 different policies with every possible combination of LLDP addressed. Port channel. There's a couple different port channeling methods that's used by ACI. We can use MAC pinning, we can use mode on, or we can use LACP. So we'll just go ahead and write for a couple of these. So I'll say, PC static on, and we'll do static mode on. Notice you can control the minimum number of links that need to be in the channel in order for it to come up, as well as the maximum that are supported by the channel. So we can only do up to 16, but you could actually lessen this down if you didn't want, up to 16 links in this particular port channel. Again, this is going to be wrapped up in a bigger policy that we're going to see later on. So this is really just the mode for, static port channels. Okay, we could create another one for LACP mode active. So I could say port channel LACP active. We could address, so we could come over here and use LACP active. Whoa. And notice when we select LACP here This suspend individual ports on, graceful convergence, fast select, hot standby ports. So these are LACP specific parameters. You guys probably remember LACP suspend individual within NXOS. Basically, if we're not receiving any LACP PDUs from the other side, with this checked, we'll actually suspend those ports on this side. Okay. If we were to uncheck this, they would operate as just individual trunks until we started receiving PDUs from that other side. So I'll go ahead and leave it on. I like them just to go off. And again, we have min links and max links in there. We'll click submit, and then we'll create another one for MAC pinning. And you guys are probably aware of MAC pinning if you've studied 1000V at all, or even UCS for that matter, because they both use some form of MAC pinning. But this is kind of handy if the upstream switch or switches do not support multi-chassis ether channel, because they don't have to be aware that on the ACI side that you actually have those ports in a port channel. So from a topology perspective, using MAC pinning, you might have leaf 1 here and leaf 2 here, and maybe they're participating in a VPC domain. And then maybe you have some out-of-band switch up here and some out-of-band switch up here, and you're wanting to do something like this from ACI, right? Well, these two switches up here aren't running VPC or anything like VSS, so we could use MAC pinning down here to kind of fool those guys, okay? Because they don't have to be aware that on our end, we're actually using a port channel, because really what we're going to be doing is, as MAC addresses come in, we're just going to be pinning them to one of those respective uplinks participating in that port channel. Okay, so within the MAC address tables up here, A would only be reachable off this link up here. And that's how MAC pinning works. Again, it's not any different. It's kind of like that VPC host mode that we used to see on the Nexus 1000V itself. Okay, so we'll go ahead and just say port channel MAC pinning, and we'll click submit here. So now we have a couple different port channeling policies that we can leverage again later on as we start to build out some of our interface policies and whatnot. We also have, spanning tree, storm control, data plane policing, the miscabling protocol. Again, the default's enabled. The only other option there, we could create one saying, MCP off, and we could click submit. So again, just being aware that the default is enabled and then MCP off is disabled. So all of these policies, that we're going to be leveraging at least, have now been addressed, and we're going to see as we start to kind of cascade through the rest of the configuration of ACI, that we're going to kind of be picking and choosing which of these policies we now want to use. And again, it's not a showstopper if you get to a point and you're like, oh crap, I forgot to configure CDP on. Now I have to stop what I'm doing, go back and configure that policy, and then come back and configure it. That way we can use it within here. It's not a showstopper, and a lot of the times you have the ability inline to go ahead and create that CDP policy or that LLDP policy. But again, this is just one of those time saver things. That's why I like to really just be able to address these interface policies up front.